Our next presenter is a veteran of the U.S. Navy. He holds a bachelor's degree of science from Embry-Riddle Aeronautical University. He is a commercial pilot as well as an A&P. He is an aircraft safety investigator and currently teaches in the NTSB Academy and the Transportation Safety Institute and also numerous fire departments. He's currently building an F-1 rocket. His topic today is accident investigation for technically advanced aircraft. Let's welcome Mr. Mike Busch.
Thank you, Walt. Good morning. Thank you for tuning in today. We want to talk a little bit about technically advanced aircraft and the accident investigations that we do around them. And before we go much further, I have to remind you that if you're involved with any aircraft accident investigation, that it's a federal jurisdiction under the NTSB. We have a lot of good folks out there who do rescues and first response and so forth, and they don't always know some of the rules, and they don't realize that this is a federal jurisdiction and that the wreckage should not be removed or moved because it is federal evidence without permission from the NTSB. So that's something I wanted to pass along right up front. So what's a technically advanced aircraft? Well, a technically advanced aircraft looks pretty complex when you first look in the cockpit, but basically it's one which would contain a GPS navigator with a moving map plus any additional systems such as advanced engine management systems such as FADEC and so forth, glass avionics, multifunction displays and so forth. It looks pretty complicated and can be fairly intimidating, but I will say that these aircraft are enabling fairly inexperienced pilots to fly very complex missions today. And in our own customer base, we're finding that they fly these aircraft a lot, so they're getting utility from these aircraft. We're flying 2 and 3 hours a day per aircraft. Cirrus has now passed the million hour flight mark of our fleet, and we only have 3,700 airplanes out there. But the technically advanced aircraft can't keep us from some of the basic accidents. We're still running out of gas, we're still bumping into things, and we're still flying VFR into IMC. So those are things that these new avionics and so forth can't help us. We are learning that although the accident rate seems to be fairly consistent, flat, hasn't decreased much, we are seeing fewer fatal accidents, which is always good. Now, some of this technology isn't exactly helpful. For example, you can go out and buy a pilot handheld GPS unit, fly around with it and so forth, and fairly inexpensively, I might add. And you'll find that it will provide what we call a breadcrumb trail, or in other words, a path that the aircraft had followed in flight. And that can be very useful to accident investigators. We want to know what circumstances the pilot was in before the accident. And you know, these are fairly inexpensive things. I think the same features are involved on some of these very inexpensive GPS that hikers use and boaters can use. But you know, these very expensive panel mount GPS units don't have that feature. Even though the technology is there and some of the same manufacturers make these various units, we don't have breadcrumb trails on the panel mount GPSs, which can be kind of frustrating for us when we're trying to figure out what happened at the site. So we have to do it other ways. Now you'll find that accident investigators, I don't want to use the word sneaky, but we do have to get innovative and think about how we're going to go about solving this mystery. And there are a lot of mysteries to solve. And that's why we call it probable cause, because sometimes we just don't get all the information that we need. But the TAAs have helped us a lot. And it goes without saying, gee, you know, if you're looking at all this stuff on the screen in the aircraft, it would make sense that at some point all these sensors pick this stuff up. It had to be processed somehow electronically and made into some sort of digital format so that we could put it on a screen for the pilot to view. How do we capture that stuff? And you know, we learned quite by accident that some of these new screens were not really designed for accident investigation purposes, obviously, but the data is there. I mean, there's an immense amount of data on these new glass panels. And so we learned quite by accident that the people who designed these things had put in a little a card, an electronic circuit board in the back for troubleshooting purposes. When the thing came back to the shop, they could use this little card for helping them figure out why the box wasn't working right. And we learned that it had a bit of a memory to it. And the first thing we figured out was that, say, you know, there's engine parameters on this. Maybe we can figure out what the RPM was or the temperatures was from this troubleshooting device. It was not designed to hold a lot of memory, somewhat like the flight data recorders have on the airliners with, you know, 1,000 channels of information. Now, GA airplanes simply don't have black boxes, or even orange ones for that matter. And so we have to go out and solve accidents the old-fashioned way. We look at the angles with the tree branches that are broken and have to actually do a lot of sleuthing without electronics. So the fact that we can sort of tap into some of these things that are being displayed to the pilot is really good news for us, and it's very exciting. So like I say, we've now got access to a lot of things that were simply not available to accident investigators previously. So things like engine run data. Now, if you're flying one of these new airplanes with a FADEC system, you can actually get 2,000 hours worth of data from this thing. You can see what the temperatures were on a given time and date and the RPMs and so forth. This is very helpful. And also we have primary flight data that we can get, and also some pilot inputs. That's really key. When you can see what switches the pilot selected and when he turned them on and off, which ones they were, this is really helpful in accident investigation. Mind you, this is sort of experimental, if you will, and we kind of happened upon this quite by chance. And so it's been taking a lot of innovation, a lot of hard work to try to glean some of the knowledge from this vast amount of, you know, of electronic stuff. You have to really do some sorting. It's not to the state of the art where we can just take a chip out of the airplane and plug it in and see a video of what the airplane was doing prior to the accident. We're not there by a long shot. We have made some strides in it, though. So the process of recovering this information and then analyzing it is fairly extensive, and it's a lot of hard work, long hours to do it, so it's not easy. So we're going to talk about that, and I'm going to show you actually some of the data that we can get and how it can help us in accidents. I'll review actually 3 accidents here in just a minute. But I keep hearing the phrase throughout the industry that there are no new accidents. I've heard agencies and representatives from all corners of the globe talk about the fact that there are no new accidents. We know all about human factors. We know about weather. We know about icing. We know what causes these things. There aren't very many mechanical things that can go wrong and so forth. And I just don't think that's quite true anymore. And in fact, with the electronic data that we're starting to get from GA accidents now, we're finding out that there might be some new twists on some old things, to the point where in the old days we used to go to what was euphemistically called a smoking hole accident, where, gee, there was just this big wreck and nothing was left. And we didn't know anything about anything. We couldn't find any parts to analyze because it all burned up or whatever. You know, you had to make some assumptions, and those assumptions probably weren't always correct. And unfortunately, a lot of times the pilot was blamed for this unhappy occurrence. I think we've come across to the point now where we're getting enough information where we can actually tell what maybe was going on, what sort of led the pilot to certain decisions, or what was going on in the aircraft just prior to the accident. And we may even want to think about some of those old smoking hole accidents and say, you know, did we really understand everything that happened that day? And the answer, of course, is no, we did not. So today we have a much better idea of what's going on out there. A couple things that are interesting today, at least on the Cirrus and many other aircraft out there, these aircraft are equipped with ballistic parachute systems. What a boon. We can, you know, get into trouble out there. The pilot can activate the system, and now we've got a live pilot to talk to, and we've got a whole airplane to look at. No smoking hole. Gee, that's pretty cool. And you know, we can also now verify some of these things with the electronic data that we can get. Witness statements sometimes are confusing. Sometimes the pilot statements are a little confusing. And so we can now back this up and compare it to other electronic data directly from the airplane. So some of the new accidents that we've discovered is that something like an autopilot stall was something that I think we speculated about, but nobody really knew, and I don't think we could prove. But we're pretty sure now that, you know, the autopilots are wonderful today. They're marvelous machines. You can put them in, you can program them for the rate of climb that you want and the altitude you want to achieve and so forth. Very reliable, very good instruments. And in fact, the autopilot people will tell you that they have never caused an accident, been the cause to one. The fact is, though, it is a machine, and the pilot has to manage that machine just like everything else in the airplane. And if you set it to do something that the airplane can't do, then, you know, things could go unraveled on you very quickly. So we have this new data, again, not easy to get to, but we can certainly use it very, very positively in what we're doing here. The other new thing I want to talk about, it's not really new. You're going to say, well, gee, distractions have been around forever. And that's true. You've probably experienced some of these yourself, and we've talked in safety circles for a long time about keeping a sterile environment in the cockpit during critical phases of flight, such as takeoff and approach and so forth. We want to keep the pilot focused on what he's doing and not be distracted by things that are going on in the cabin or the kids getting nervous or whatever. And so the avionics people have provided a little button on the audio panel that allows the pilot to be isolated from that distraction so he can work directly with ATC without being interrupted. So distractions are certainly always an accident factor. And you've seen some of these new ones today yourself, probably even on the way in this morning. There was probably somebody in front of you talking on a cell phone. And I can tell you that that is absolutely a new cause for accidents. We've recently in our own fleet this year, we know for a fact that the pilot was in a very busy environment. He was multitasking as pilots do, and he was actually talking on the cell phone during that time and was distracted by it, to the point where he did lose control of the airplane and was not able to regain it. Now we know this because, number one, we recovered the cell phone, and number two, we talked to the person who was on the other end of that conversation. And so we know that people are out there talking on their cell phones in airplanes as well as in their cars, and it can certainly be a distraction. I think we take the safety of aircraft for granted, and we feel like we're maybe bored and have to call somebody and talk about the whole thing. That's not necessarily a good thing to do, but it's happening out there, and so it's something we have to really watch these days. So a couple of the accidents we're going to talk about, we've talked about these GPS units that you can buy that leave a breadcrumb trail but do not in the airplane, and we can glean some of this data now from the glass panels, which can show us all this information, which is really good. I hope in the future that we will be able to extract it much more easily. And from this, we've actually started doing some research on very simple data loggers, and Cirrus is in the middle of this as well. A data logger is simply a hardened chip that's placed someplace strategically in the aircraft, for example in the tail, where it won't get damaged, and it plugs directly into this data bus and will record vast amounts of information, so we don't have to go through all these stepping stones I'm going to show you about. And again, it's really important to see what the pilot did and when he did it. So we've talked about no new accidents, and I'm going to give you some thoughts here. The second distraction that it's been around for a long time, but we haven't really considered it much, are cameras. New digital cameras are really great. They can do a lot of good things, and people have taken a new interest in photography, and we find a lot of people out flying around trying to take pictures of their house and stuff, and we find that they're getting distracted by the mission rather than paying attention to what they're doing. And this has been a situation that we had, for example, down in Bull Bay, Jamaica in September of last year. This is an accident of one of the three I'm going to talk to you about. You can see from this data that here we have the runway and the sort of breadcrumb trail, if you will, that we were able to extract. You can see that the aircraft climbs and eventually descends rather rapidly from this picture. And the next one will show you that this aircraft flew across the bay and then actually had an accident. Let me tell you what happened real briefly, and if you'll forgive me, I'm going to read some of this so I get it right. But we had 4 occupants in an SR-22. And we all know that just because you have 4 seats in an airplane doesn't necessarily mean you can fill them all up, especially if you have full fuel, which we did on this particular day. Down in Jamaica, the temperature is always about 90 degrees, give or take 2 or 3 degrees year-round. So these people certainly were used to flying in these conditions, but it was still hot. And the pilot had programmed the autopilot on this particular day to climb at 1,000 feet a minute. Now the Cirrus will certainly climb at 1,000 feet a minute, but if it's all loaded up, it may not perform at 1,000 feet a minute to the intended climbed altitude, which he had set at 9,500 feet. Okay, so he takes off, and they climb to 4,300 feet over a 2.5 minute period of time. And basically, from the data that we recovered later, we could see that the airspeed was declining during the whole time he was climbing. Mind you, a steady rate of climb, but the airspeed was just coming down. Got all the way down to 72 knots at 4,300 feet. The aircraft pitch attitude, we could read, went from 20 degrees nose up to 78 degrees nose down rather suddenly, and followed by, as you might imagine, a rapid descent. There were large variations in pitch and roll during that period of time, And for the next 15 to 20 seconds, the pilot's altitude decayed by 2,000 feet, which is a significant drop in altitude. The pilot realized that he was over his head. He reached over and pulled the handle for the caps, the Cirrus airframe parachute system, and all 4 people came down safely. And you can see in this data here that we did just that. It came down straight down under parachute, which was really great. Now it turns out, after we talked to the pilot, who was still pretty shaken up by this, that we could clearly see that the people were on a photo mission. These are the pictures that we retrieved from their cameras. Now that's not exactly TAA stuff, but we could see that, yep, they were up there taking pictures and they were not paying attention to what they were doing. They mismanaged the autopilot. Had he set it for 500 feet a minute on this particular day, probably would have worked out all right. But these are the pictures we got from this particular one. So not paying attention to managing your systems and the autopilot can be a problem, and we can read this data now, which is pretty good. So this might have been an accident that would have been ruled loss of control, for mechanical reasons, because all we would have had again is a smoking hole. Nope, this time we had a parachute available, and we saved 4 people, and we were able to talk to them, and we were also able to look at the airplane. So that was really good. This is up in Massachusetts in August of last year, up 2007. Now, I don't expect you to be able to see this, read it exactly, but we get pages and pages and pages of stuff that looks just like this. It's hardly easy to read, and you have to just pour through this. It's kind of like reading a dictionary. It doesn't make sense until you start comparing and analyzing. So this data, while it is available, isn't necessarily in a user-friendly form. And what we can do is, on this particular case, we have a VFR pilot flying into an IMC condition. And what we can do here in the white letters on this particular slide, you can see that these are the transcripts that we got from ATC. The red letters are the pilot's replies to ATC. Along this pink breadcrumb trail, which we extracted from the aircraft, are times and places of when he was actually communicating with ATC. And we could also now kind of overlay this with radar data. Radar data is really good if you can get it. Sometimes you can't. And sometimes radar data can be fairly inaccurate in that some of these radars turn at different speeds. And so you get a hit every 4 seconds or every 7 or 11 seconds or something. So you get this sort of dotted line, but you don't necessarily get the whole picture of where the airplane was, because at cruise speed, certainly in a Cirrus, you can cover a lot of real estate. With this kind of information, we can now see a complete picture with no holes in it and know exactly what was being communicated, where it was being communicated, and so forth. This particular occasion, the pilot was flying into the instrument conditions. He asked to shoot an instrument approach. The tower asked if he was instrument qualified. He replied that he was. In fact, he was not. And he then proceeded to try to fly an approach to this thing. We know from our data exactly when he switched over to the ILS frequency. You can see this. Now, this may be a little hard to see also, but we were also able to track his entire path from this. And furthermore, the NTSB was able to work with this, and I'm going to enlarge this a little bit for you. You can see the actual attitudes of the aircraft during this period of time. Clearly, the pilot did lose control in IMC conditions, and eventually they pulled the caps again, and the 2 occupants, although were injured, they did survive. The problem is that as they came down, the parachute canopy hit a guy wire for radio tower, and it kind of came down a little differently than we would have liked. But basically they walked away from the accident even though they were injured. So we can get this kind of clarity and this kind of data, but we have to work at it. It's tough. One last one I'll talk about is a situation down in Luna, New Mexico we had back in April of last year. Again, this is what the data looks like, and there were pages and pages of it. It looked like a whole ream of paper with these printouts on it. So it's very time-consuming, as you can imagine, to go through this and find the right stuff. We hope to improve on this with the data loggers. But basically, this gentleman had a flight that was going, let's see if I can figure it out here. He was going from Tucson to Denver. He had an IFR flight plan. He was a low-time instrument pilot. Late afternoon departure, took off and filed an IFR flight plan. In fact, did take off IFR and was climbing up into the clouds when the aircraft started accumulating ice. He asked for a higher altitude, which he received, and started climbing a little higher, was not able to get up to 17,000 where he had been cleared, and realized that he had to come down. He asked for lower. He got that from ATC, and then he said, "I'm descending right now," because he realized that he was losing control. About that time, we were able to detect that the static port had iced over, and in fact, the stall warning went off in the airplane. Now, he was in the clouds, and so he assumed immediately that he had stalled the aircraft. Okay, and so during that time, the airspeed indication went to 0. Altitude went to kind of goofy, as he said. All the numbers on the PFD were in red, which would be a bad sign. And so he kind of forgot that he'd been on autopilot this time and just sort of stuffed the nose down to get it down. And he was doing okay. He may have actually had time to sort of recover the aircraft, but just below 8,000 feet, the TAWS warning went off. This would be the terrain warning, which is also part of, the TAA. It's saved a lot of folks, by the way. So the TAA goes off, bzz, and he says, that's it, I'm out of here. He pulled the handle on the CAP system, and it takes a few seconds for this thing to deploy. And the accident site was, in fact, at 8,000 feet. And we figured that he had something like a half a second between the time the chute fully deployed and the time he impacted the ground. So there you go. Probably not mining manners here, but we have a little depiction of not only where he was, but also what altitudes he was at during that period of time. So we can overlay this data. We can get a pretty good idea now of what's going on. It's a lot easier for us to do these kinds of things. Now, I go out and talk a lot of places around the country and to a lot of investigation outfits, the NTSB, FAA, and also some first responders, such as the Civil Air Patrol and a lot of fire companies around the country, because a lot of these folks don't really understand that in some of these new airplanes, not just limited to TAA, we have new recovery systems. I've mentioned the CAPS for the Cirrus Airframe Parachute System. It's a ballistic parachute system which can be deployed. There's something like 26,000 of these installed in various aircraft around the country. And to give you some perspective of how many that is, we only have about 23,000 privately registered business jets, if you will. So there's more parachutes flying around than we have business jets right now. And we expect that number to double within the next 2 years. We also have airbags on board these aircraft, and the problem is that if the pilot doesn't use some of these systems, especially the BRS, in the course of the accident, now we have a live rocket charge at the accident site. And so a lot of people don't realize that there's some hazards involved, and I'd like to kind of address those really quickly if we can go through this. By the way, the fellow going to Denver, we noticed that the PDOT heat was never turned on, which is why he lost all his numbers. He did figure that out, and when he did turn on the PDOT heat, he immediately got some airspeed indication of 159 knots and so forth, but it was too late. And when he got the TAWS warning, that's when he punched out. So this is very clear what happened on this one. So the new technology does present some challenges to read and analyze, and there are some rewards in that we can get good, meaningful data, and then we're going to talk about some hazards with these new safety pieces, which means that we have to think differently when we go out and to an accident site for investigation purposes, rescue purposes, what have you, and realize that these things can be on board. And it's not necessarily very easy to tell that they are on board because there are no external signs on them. Particularly, we have a little small one on the Cirrus, but by the time you get on top of it and can actually read the sign, you're probably too close. By the same token, on cars today, we don't have external warnings about airbags inside of cars. That's on the visor, as you know. And so I think that we may not ever be able to get legislated big signs on the airplane, and maybe that's not necessary. So I'm telling you that some of these devices can be in airplanes, and if you go out to a GA accident, certainly a single engine accident, your chances are better than 50% that we're going to have either airbags or a ballistic parachute system on board that aircraft. And you need to just be aware that it's there. It's better to know that it's there and find it than to be surprised by your discovery. That can be hazardous. So we're going to say that you just have to change how you think. Just assume it's like a loaded gun, always loaded, and just beware. So that's the ballistic parachute system. We have the AAIR, which is the airbag system made by AmSafe Aircraft Inflatable Restraints. They're doing a great job. NTSB is doing a study on those now today. They're finding that these devices work really well as long as you plug them back in after you've taken the seat out. That's the only failure we've had, by the way. Composites, a lot of these new aircraft have a lot of composites in them. The Cirrus certainly is an all-composite airplane. We're not alone in that respect, and there's some hazards you have to recognize and respect at the accident site. And a little thing that I learned a couple months ago when I was up in Seattle, this is maybe a little hard to see, but in the On the Cirrus doors and many other aircraft out there, we have these pneumatic and/or gas struts that will actually hold a door open or assist you to open a lid. You probably have some on your car, on the trunk lid or something. I was talking to a fireman who said that his people were working a truck fire one day. They had an engine on fire, and of course the hood was open. And eventually the fire was able to melt the ends that retained this particular device, and the device, because it was pressurized, shot across the accident site about 30 feet into one of his men's leg. Now, had he struck a vital area on this fellow, he probably wouldn't have made it, but as it turns out, it kind of passed right through. So it's these little things that you don't think about really when you're on an accident site that can get you. It's just something I talk about all the time because I didn't know about it. I'm thinking, gee, we got 3,700 airplanes out there. They've all got 2 of these struts. Composites are a wonderful thing, and as you can see from this picture, they're very crash worthy. Okay, this is a deer hit on a SR-22, and we've actually had one guy that hit 5 geese in flight with an SR-22 and managed to land safely, and the aircraft was repaired and returned to service. Fiberglass and composites, as we call it now today, do change the equation as far as safety is concerned. They fail differently, they fail incrementally, they absorb energy very well, and accidents that happen out in the field with composite airplanes typically have people walking away from them, in which would have been fatal otherwise. And that's why I'm saying, although TAA hasn't maybe yet changed the equation exactly, we're finding that people are walking away from accidents. Still having accidents, but they're not fatal. That's really a good thing. So this is very crash-worthy stuff. Now when you go out to the site, this will break up and be in pieces, and like anything else out there, we can have fires and we can have smoke and so forth. This is a typical site. As you can see, the aircraft's off to the left there, but the smoke right in front of you is from the forest fire. And this stuff is no good for you either. It's got carcinogens in it. Some of the airplanes today, even the experimentals out here, my Long Easy, for example, had urethane foam in the nose, and when urethane foam burns, it certainly gives off toxic chemicals. So that's something you have to be aware of when you're out on these sites, not just with composite airplanes, but we certainly bring it up when we're talking about composites. So we encourage people to approach the site from upwind. A lot of splinters can occur if the, for example, unidirectional glass carbon pieces still have some resin around them. They can be almost like knitting needles that are very sharp, and you can be severely injured if you happen to step on one. Now, when you're out on the site, you're being aware all the time. Your head's on a swivel, as they say. You're looking everywhere. It's rare that you're actually looking at your feet and looking at what you're walking on, and that's where you're going to get hurt with these things. And it can be a very painful thing, and of course you can get pretty injured. And a lot of these sites are in the middle of nowhere, and so if you're injured on a site, it can be a more serious situation than if you're in town, for example. So these are some things that we caution people about out on site. These are pictures of some of these shards, some of these pieces that you might step on. I know it's kind of hard to discern exactly what they are, but they can be everywhere and anywhere on a site, and so you just have to be aware of what's going on. Now the airbags are automatically deployed, unlike the CAP system, which the pilot has to activate. These are working very well, as I said. They're protecting the occupants from head and upper body injuries, and they are available in a whole spectrum of aircraft. In fact, when I first started talking about them, I had a little list of who had them and who didn't, and that list is so long, and we're getting approvals every day for retrofits on these, to the point where I don't even have an idea who has them. It's being very popularly approved, and they're going in a lot of airplanes as standard equipment, and you can retrofit them to just about anything out there now. And I think it's going to be just like the cars. At some point you're going to find airplanes that have airbags on board as standard equipment right across the board. Here's what a Cessna 3-point harness looks like, and of course the airbag's in the lap belt portion of it. And on the Cirrus we have double shoulder harnesses, and the bag is actually in the outboard side. I'm just going to quickly show you a movie of how these things deploy. It's just a short shot here, and you'll see that the bag actually deploys initially away from the occupant, if the movie will run. Some days it does, some days it doesn't. What this movie would show you when it gets caught up is that it will deploy initially away from the occupant and then actually vent at the same time, and that's to allow the occupant to get out of the cockpit 10 minutes after deployment. I'm sorry the movie isn't working. Well, here it goes. Okay, well, we'll just kind of watch it in steps here. Notice that there's kind of a white powder coming out of it. That's actually helium, and we want that bag to deflate within 10 seconds of deployment, so it's easier to make your way out of the cockpit. Well, it's not going to cooperate, so we'll just keep going here. These are what the components look like. We have a helium bottle and also the brains for this thing. And they're better than a car system. They have a much better trigger on them. They're safer for the EMTs to work with. And you know, the car system was not very well touted by the automotive industry, and a lot of first responders actually got hurt because they didn't know they were there. That's something we want to avoid. Okay, so I'm going to just kind of zoom through this rather quickly. These things are powered independently. We can actually put them on the floor right here and make them work. You don't shut them off by taking the battery out of the aircraft or cutting the cables. They're absolutely independently powered so that they work all the time. To disarm them on a Cessna, for example, it's got a little magnetic switch in the 3-point harness, and you just simply unbuckle there and it will disarm the system. The Cirrus, well, before I go to the Cirrus, we'll just say on these Cessna and Mooney 3-pointers and so forth, you want to not connect these when the airplane's not being used, because that does arm the system. In the old days, we clean up the airplane, hook all the harnesses up, and then we'd say, well, okay, looks nice for the customer. We don't want to do that anymore because it does arm the system. On the Cirrus, it's a little different. We have these little 4-point cannon plugs that we have to disconnect to disarm them at each seat. You have to pull them apart, and they can, well, they're designed to stay together, and so it's kind of hard to get them apart, but you do have to do that to disarm them. And you can also, if you're an investigator, you can cut the cable right here if you're in a hurry. We've also learned that if you take the seat out in a hurry, that it'll break right there also. And I'll just go very quickly to the parachute systems. Basically, these are very safe and reliable systems. We've saved over 208 lives with them worldwide. And our job here is to try to tell you that they're in there and just to be cautious with them, working around them. You can find them in a lot of different airplanes. As I said, there's 26,000 of these things out there, only 3,700 Cirruses, and so we're less than 10% of the total. Here you see a Cessna, standard looking Cessna. This one is equipped with a system. You can't tell by looking at it. So that's why I said earlier, you have to assume that these things are in there and be safe, and be disappointed if you don't find one. And I'm going to say that these are approved, of course, for the Cessna 150s, 152s, 172s, 182s. I'm going to show you right now a test on one of these systems, if we can get the movie to run. And right now it doesn't seem to want to do that. Oop, here we go. This is a test we did for certification on a 182, and it's just not coming up. I'm sorry. Well, what it shows is the actual rocket pulling the parachute out of the back end of the airplane through the rear window. That's a place that a lot of people don't expect the parachute to come out. So if you're on an accident site and trying to figure out if there's a parachute in there or not, look around. You'll see a red T-handle, such as this one. This is on a Flight Designs aircraft, CT. You'll find these handles all over the place. You'll find them on the floor in the Cessnas. You'll find them in the ceiling on the 150s. You'll find them overhead on the Cirruses. Sometimes the whole thing is exposed to the outside. Here you see a canister that contains the parachute, and also right next to it is the actual rocket. This rocket simply pulls the parachute out of the canister, in this case, gets it away from the airplane so it can open automatically. And the key is that all these are connected with a cable. This is not an electrical cable. This is a housed cable like you might have on your bicycle for handbrakes or clutch on a motorcycle, perhaps. And there's lots and lots of little airplanes that have these things. You'll probably find a lot of them right out here at Sun and Fun. So what's a rocket look like? Well, typically they're cylindrical. They'll have a cable attached to them, something like that. If you see that thing, you need to call somebody. They come in all sizes, but typically they're cylinders, and you wouldn't necessarily identify them as a rocket by looking at them. These are some of the components that we look for at the accident sites. If you see these things, then you need to call somebody, and that somebody would be Cirrus. We have an 800 number, which I'll show you in a second. These are the cables that activate these things. And the pilot has to work these things. We do not have automated parachutes, and we want to give the pilot some latitude on what to do. He may simply have lost an engine, may simply be able to make an emergency landing, which of course all pilots are trained to do. And he may want to do that instead of pulling the parachute. So we can't shut these things off. They're always on. In the Cirrus, we pull a handle like this, and I'll go through this cartoon relatively quickly because it shows a cross-section of the rocket and the igniter and how this works. We'll pull the handle. The cable will pull on this igniter at the bottom of it. And if you look at the bottom of the picture here, you'll see this spring collapsing, which is part of the igniter. Cocks and fires all at the same time. It's almost instantaneous, and that's how we get the rocket to go. It again just pulls the package out of the airplane, and it's very successful. Works fine. And my slides won't go forward now. Okay. So we can do it manually. Here we go. Oh dear. Okay. This other hazard that we're concerned with is the parachute can't be detached from the aircraft. And in this particular case, we had a gentleman lose control of the airplane, and he decided to pull the handle, and 3 people landed safely, and they walked away from the airplane. Well, it was in a part of the country where it's very flat and very windy, and the parachute, which is huge, got inflated and pulled the airplane over backwards and actually dragged it several hundred feet. And so thanks to the FAA, they were able to clip the cables on this thing before it got to Texas, and we were very happy about that. But it is a hazard you have to be aware of if you're out there working on the site, that these things can drag the airplane some distance. So we want you to work from the upwind side, and if you have a fireman handy and they have a hose and truck available, wet the parachute down so that it'll collapse. It's the best way to do it. And then once you've got it collapsed, you can park your G car or some other vehicle on it so it won't inflate on you again. We also recommend that people approach the aircraft from the front or the sides. As you can see here, try to stay away from the back. That would be the barrel of this thing, as it were. So you want to stay away from the back in case it might deploy. And we also want you not to cut into the top of the airplane, because that's where the deployment cable is located. So if you were to, for example, snag that, it might actually deploy the rocket if it was still in the airplane. When you go to one of these things, please never pull the handle to try to disactivate or deactivate it. Say, well, if I pull the handle, on my terms, we know that it went. Don't do that, because if during the course of the accident the propellant got mangled or broken up inside there, it will burn at a different rate than was designed. And the nozzle is only designed to take so much thrust. So you could have yourself a really big road flare on your hands, or worse. So we don't want that. The FAA, in fact, said, look, we don't want our people to be bomb disposal experts. So if you see these things, identify that you have them, notify somebody, and that somebody to notify is Cirrus. And in fact, I get calls from people who aren't even involved with Cirrus. The FAA's called me on 5 occasions, as late as last year, on aircraft that weren't ours. They say, hey, you're the rocket man. I heard you talk down in Oklahoma City. Tell us what to do. So we'd walk them through it. Here's the number. It's an 800 number. You're going to be met by a live person, not a robot. So when you call 800-279-4322, you're going to be able to say, look, I want to report an accident, and we need to talk to somebody in air safety. And that's the number you're going to get. And that's the person you're going to get, one of our people. Please do not call the bomb disposal squad. Bomb disposal squads only have one mission in life, and that's to blow stuff up. We have to remember this is federal evidence. And we want to look at this piece of the aircraft along with everything else that we do to see if it worked, how well it worked. This is evidence, and it's all part of the investigation. So we don't want them removing things, first of all, and then destroying stuff, which is what they do. I've been out many times to disarm these things, and this is an old slide, but it seems to work pretty well. And our guys are very serious about this. I mean, they're very good at doing this. We've got the right tools and the right training. And so when they're doing their job out there, we'd recommend that you kind of treat the situation seriously and not do any pranks. The firemen love to pull pranks on each other, so I put this picture in for them. They usually like that. How's the best way to get the word out to people? Cirrus has actually got a DVD that we offer. It's free, looks like this. Inside it's got a shirt pocket guide in the pocket, as well as a DVD and my card and the 800 number I talked about. The guide talks about what to do if you encounter a rocket or a ballistic parachute system and or the airbag system. What to do, who to call. It's all right there. It's only about 15 minutes long. It's great initial training, and it's really good for recurrent training too. We've shipped out thousands of these things worldwide to fire departments everywhere, and a lot to the FAA. So if we have a few minutes, we would open a thing for questions if you have them. If we have time.
Just hold your hand up and we'll have someone bring a mic around.
I have a couple questions and one comment.
Sure.
One, I used to fly the ATR for American Eagle, and
Okay.
We weren't allowed by our either by our procedures or ops spec to use the vertical speed mode. We could only use indicated airspeed mode specifically for the instance you were talking about.
Yep.
I don't know if that's being considered in the training.
I can't answer your question directly. We're getting better at training people to deal with these new airplanes, the new knobology, if you will. And a lot of flight schools have actually bought Cirruses so that their people can train on our aircraft so they can get into commuters at some point that are pretty well equipped today. We also are doing scenario-based training because we have a sim, and we actually put them into situations where we make them reach for the handle. And that's turning out to be a very, very valuable tool for us. We can also use the sim when we take this data out of the airplane. If we can reconstruct a lot of the path, as I said, the speeds and so forth, we can actually plug that whole scenario into our flight simulator and fly it again and see maybe what the pilot was seeing. So that helps. I can't answer your question directly about the airspeed zone. I'm sorry.
We found that helpful. It avoided the vertical speed scenario where the airplane wouldn't perform. The indicated airspeed mode was a real lifesaver for distractions.
Okay. Thank you.
I have a question regarding the accident which they went for photo. My understanding from your narration is that they went up to 4,000 feet and then they start either stall or spin whatever they have. When you were talking or investigating with the pilot, did he realize that he was installed and did he know how to recover or just left it?
Well, sometimes it's difficult to understand the pilot because they've just survived a life-threatening event, and sometimes they're very clear on what was happening and they know exactly to the second what it was. They can talk to you as if it was a slow motion movie, and others can't tell you their name at that point. And so we get all kinds of replies back to our questions. In this particular case, the gentleman was pretty disoriented and didn't really understand much, and we weren't able to get a lot from this particular pilot. But it's very clear that they were more focused on shooting pictures than they were on flying the aircraft. And although the settings on the autopilot initially were okay, they weren't managed very well because you reach a point on the settings that he had that the airplane's not going to be able to fly. And the autopilot was doing what it was told to do. It's just it was a heavy, hot day, and the airplane just couldn't perform, so it eventually just pitched down. I think it's fair to say that the pilot and the occupants were distracted, and I don't think there's any argument about that. And it's always sorry that these things happen, but we're very grateful that they were able to survive thanks to the parachute. And the data showed us what was going on. We did see the airspeed decreasing to a point where he should have picked that up and readjusted the autopilot or started flying manually. He had those options, didn't see it happening, and all of a sudden it just pitched down. That's when he first became aware of it. Yes. We have a lady over here, yes.
Mike, I'd like to know how you have developed your training to include management of the autopilot. It seems as though autopilots are very important in a TAA aircraft.
Autopilots are indeed very important. They're a critical piece to the puzzle because these airplanes, first of all, are very capable. They can go long distances, and it's kind of tiring to hand fly the whole time, and so people tend to use the autopilot a lot. The autopilots today, right across the board, are very, very reliable. They're great pieces of equipment, and they have a lot of capacity. We've learned now that when we do a delivery to one of our customers, we have what we call a transition training course at the factory, where the pilot comes to pick up his airplane. We actually put him in his airplane, and after he has accepted it, then we'll go out and train him for up to 3 to 4 to 5 days to make sure he understands, as we say, all the knobology, where everything is located, and more important, how to use it. And we teach them the autopilot very, very carefully because we know they're going to use it a lot. Again, we do a lot of scenario-based training in the sim as well. And we want to make sure they understand how to disconnect it, how to manage it, what the capabilities of it are, what the capabilities and limitations of the airplane are. And we try to marry all that together in that 3 to 5 days. And I think we've been very successful with that, to the point where, as I say, these TAA airplanes are showing that relatively inexperienced pilots with the automation, help of automation, can really become quite productive. The one thing that we caution people about, though, is to not fly on automation into some place where you don't want to be if automation should go away on you for some reason. So that's the thing we stress there.
Yes, hi. I understand that this is about, the NTSB showing up for accident investigations. And I have a situation where last November I had a catastrophic engine failure, those are the FAA's words, over the mountains of North Carolina. But I was managed to get an airport under me and a runway in front of me, and I landed safely. And it was just completely quiet. There was no personal injury. There was no property damage, except for the engine itself and a few dents in the cowling from parts flying around under there. And I left the scene, and the people that were there, the people that were managing the FBO, called the FAA in, and they came in and took pictures and left. They've never contacted me. I've never spoken with them. I've called the NTSB, and they're taking kind of a passive interest in this because it's so low profile. And I was told that this engine will eventually be shipped back to Teledyne Continental, and it'll be swept under the carpet. They're supposed to do an analytical, which means an analysis of what happened. And there's a number of people out there that have this kind of engine that want to know just what happened. And I've been told that, well, it wasn't my fault, and we don't know yet whether it was a maintenance issue, whether it was a factory issue, or what was going on with that engine. But there's a number of people that want to know. But since it's so low profile, it gives Continental the opportunity to just say, well, it's on the shelf over here, and it'll be forgotten about. And because it's not NTSB driven, this is what I'm told, the analytical is not NTSB driven, that it's going to take its time. It could take 6 months to a year before they get around to it, if they even decide to do that. And so what can we do to try and move that process along, even though it's very, under the table, it's very low profile compared to some of the accidents that happen out there?
Well, there's a number of things we can do. First of all, I can assure you from having been on numerous accidents over the last 9 years that when we form an investigation party, you'll have an NTSB person, an FAA representative, and an engine rep and an airframe rep at the site. So there's typically at least 4 of us there. We form the team, and it's kind of a lightweight team, but we actually are very good at putting these teams together and working very well on it. Regardless of whether it was an investigation or not on it, which probably is not required, TCM, I can assure you, will tear that engine down. They do want to find out what happened. And so my recommendation today to kind of accelerate matters is that you go over to the Continental tent today and ask for Kirk Nelson. He's there. He's a rep. He understands this very well. I don't think the guy that runs analytical is here today. I didn't see him yesterday, but he could be here. And his name is Terry Horton. And if Terry's here, he's the one that would schedule that. Mind you, anytime they get a fatal accident or an NTSB coded accident, yes, they will put a priority on that simply because that's really important too. But they'll shoehorn you in, and I assure you they will go through that engine. Now when they do it, it happens fairly quickly. We can typically go through an engine in about a day or less, depending on what the issue is. I think the longest one I've ever been on was about 2 days. Typically the shortest one's about 3 hours. So somewhere between 3 hours and 2 days you can have a written report saying what actually happened. Terry Horton is the manager of that particular area. Kirk Nelson is the contact here at Sun 'n Fun. He is here. He will be here all week. And they're at the Continental tent. That's the best I can do for you today. And yes, sir, that will work. They're very good at this, by the way, and they're very diligent on doing this. I've been through a number of teardowns. Yes. Okay, anybody else? Yes. We appreciate your questions. Go ahead.
Do you know, and this is outside the accident realm, do insurance companies, when people pull a parachute in a $300,000 airplane, do they look at that? Do you know if they cover it, or they say, sorry, that wasn't an accident?
I'm glad you brought that up. It's a good point. I think there were some wives' tales out there in the early days that, gee, if you pull the handle, you destroy the airplane, automatically. And it took a while for people to understand that, fiberglass and composites are very repairable. And of the 12 deployments that we've had, 10 of those have been not only repaired but returned to service. The other 2 weren't even recoverable. One of them was at the bottom of the ocean, and another one was really broken up when it hit the Hudson River. So I can tell you that they are very repairable, and for that reason, it's a fairly expensive airplane. We can actually do repairs on it, which in the insurance parlance is economically feasible. Let's say you have a $400,000, $500,000 airplane, you can sometimes fix it for $125,000. That looks to an insurance company like a really good deal. And I also might point out that when they come down under caps, they don't have to pay a death benefit. which, gosh, that should be in their accounting somewhere. So we think that it's a really good deal, and they do have the ability to fix these things. We do have composite classes that we teach at Cirrus, at the factory. We also have 160 some odd service centers out there that are capable of fixing these things, as well as a number of independent people that can fix them. So composites are truly a boon to the industry, and they're very crashworthy, and they are very repairable. I hope I've answered your question. Okay, well, I thank you for your time and your patience this morning, and welcome to Sun and Fun, and go out and have fun. Thank you very much for your time.
Good idea.
Okay.